So for time value of money, you can use Excel to complete the calculations. You don't have to do everything manually. In Excel, time value of money functions, in order to set up a function, you start with an equal sign and that specific function name, and then in parentheses you will have several parameters that you need to specify, and the sequence of those parameters are rate, NPER, or number of time period, and then PMT, which is a repeated constant cash flow, and then PV, present value, and FV, future value. So basically, this is a function to help you deal with the time value of money calculations without using that equation that you learned. But in order to do that, let's consider the example of $100 today, 2% interest rate, how much money you will have in 2 years. Since we're solving for future value, first you start with FV. This is the name of the function, and then you input those required parameters in parentheses, starting with rate. And we have a 2% rate, and NPER, that is number of periods. So we're trying to figure out the future value 2 years from now. PMT, this is a variable that represents repeated constant cash flow, because we're talking about $100 today is a single cash flow, so we don't have PMT. And then finally we have 100, which is PV, the present value that we want to put into the equation. So you close the parenthesis and now hit enter. The result is 104.04. This is the future value of $100 today at 2% interest rate 2 years from now. You may notice this answer is red and in parentheses that indicates in Excel this is a negative number. So what does that mean? If you have $100, the future value will be negative 104.04. The reason that Excel is set up this way is because whenever you complete a time value of money calculation, Excel consider this a full transaction or a round trip transaction. Think about this. If you deposit $100 into a bank account, 2 years later, what can you do about the $104.04? You can withdraw the money from the account. So at the beginning, it's $100 into the account. 2 years later, it's $104.04 out of the account. Or if you look at this situation from your personal perspective, you have to give up $100 at the beginning in order to get $104.04 back 2 years from now. So this is, in this case, 100 and 104.04. Those two represent the opposite directions of cash flows. That's why the answer is negative. What if you want to have a positive FV? In Excel, all you have to do is to change the PV, because if you have positive PV, FV will be negative. But if you enter a negative PV, then FV will be positive. So that is how Excel is set up in terms of the directions of cash flows. And the way that I just showed you the calculation is pretty straightforward, pretty simple. It gets the job done, but it's probably not the best practice, because if I want to know the future value of 1% interest rate over 2 years, or if I want to know the future value of 2% with 2% interest rate 3 years from now, I have to enter into the function itself to change those inputs. And not everyone understands how to use Excel or each number, each variable in the function. So the best way to show this and set up an Excel function that can be more flexible is that you separate the inputs from the function itself. In our example, we're talking about the current deposit, $100, and the time frame, 2 years, and then we have an interest rate of 2%. So instead of embedding all three parameters in the future value function, let's separate them, and now enter future value in the function equal future value. Now you tell Excel, okay, the first parameter we need to enter rate. Go to cell B5 here, click on this. B5 will be our rate, and MPER, it will be 2 years. PMT, because we don't have that repeated cash flow, we can type in 0, and then ask Excel to go to B3 to retrieve the value of PV. Once you close it, hit enter, 104.04. If you want to have a positive future value, you can change the input of PV to negative, or you can put a negative sign in front of FV. Once the negative 104.04 is calculated, just change its sign. Now it becomes positive. Why is this approach? It takes a little bit longer to set up this portion of the spreadsheet, but it's a much better way because it gives you the flexibility. If the interest rate is not 2%, all you have to do is change the interest rate in cell B5, change this to 1%, hit enter, and then future value will be recalculated automatically by Excel. Excel will do all the work for you. All you need to do is to specify the inputs. What if we have 2% interest rate, and I want to save the money in the bank for 3 years? Change it to 3. Now you will have $106.12. The typical practice we do is to change the color of funds for all the numbers that you will allow the user to change. So if you receive a spreadsheet, a model that put together by someone else, and you see blue numbers, that usually indicates those are the inputs that you're free to adjust, to change. And the rest, like the 106, is not a hard entered number, but it's a formula, and you don't want to touch it. So what I just showed you, the FV calculation, I started by typing in, okay, because I know the function is FV, so I type in equal sign FV, and then once Excel receives the message, okay, this is the future value, and then will remind me this is the parameters or inputs for future value calculation. But another way to do that, especially if you're not familiar with the name of the function, you know what you're trying to calculate, but you don't know the precise name of the function in Excel, then you can use this dialog box. If you come here, click on this icon, it's a function icon, it shows insert function. Click on that, and then there will be a box related to Excel functions, especially if you don't know what the name of the function is. You can type in some keywords and want to find future value. Go, and then Excel will list a number of functions that are associated with future value, and you can click on each one, and then at the bottom it will explain what this function will do for you. For example, if you select FV, FV function returns the future value of an investment based on periodic, constant payments, and a constant interest rate. So if you select that, when you click OK, it actually gives you this new window. It's continue to ask you for inputs. Then you can reference, for example, when the cursor is in rate, you click on the space where interest rate is located, B5, or you can even directly type in the cell reference, MPER, number of periods. I can type in B4, and then you can see on the right hand side it shows now the value of MPER is based on the value in B4, cell B4, and the value is 3. So if you continue to do this, and then PV, use a negative 100, it will give you the same answer. So there are different ways to set up Excel function, and this allows you the flexibility. Now let's use Excel to deal with a retirement planning situation. What we talk about is that an annual deposit of $6,000, and then your retirement time is 25 years, and then the return, the annual rate of return is 12%. So what we tried to do earlier is to figure out how much money you will have after 25 years, making the constant $6,000 deposit 25 times. So again, it's a future value calculation, and you can enter the rate, number of periods, very similar, but this time, remember, $6,000 will be deposited every year. It's not a one-time deposit. It will be deposited every year over the next 25 years. So this will be PMT. PV, in this function, PMT is the repeated constant cash flow. PV is a single cash flow at the beginning of the time period. So with that, we have the rate of return is in E5, 12%. The time period is 25 years, which is in E4. PMT, repeated cash flow, $6,000, and then no present value. Hit enter. The answer here is $800,003.22. Again, it's negative because if you continue to deposit money into the account, when you retire, you will be able to take money out of the account. But the value is 800,000. That's the idea, compared to the 150,000 you put directly into the account. That's a big difference. And also, if you want to see the effect of monthly compounding or monthly deposit, again, you can do this future value calculation, and the rate 12%, but the necessary adjustment is that if you make deposit every month, then the rate needs to be monthly interest rate or monthly rate of return. MPER will be number of months, and the repeated cash flow will be the monthly deposit. So I'm going to divide, because if you have 12% annual rate, you're earning 1% per month. And how many deposits? Now we have 25 years, but 12 deposits each year, or 25 times 12, you will have 300 equal monthly deposits. How much is each deposit? It will be $6,000 divided by 12, or $500. With that, and no present value, close it. So you're going to have close to $940,000, substantially higher amount because you saved money earlier. So the time value of money can be applied to mortgage calculation, and we can use the same tool using Excel to calculate monthly payment. Remember, the mortgage feature, you have loan amount, interest rate, and the term to maturity. And in our example, we're going to borrow $500,000, and the interest rate is 4.25%. And this is a 30-year mortgage. So if you want to solve for monthly payment, the unknown or the function you need to use should be PMT. Previously, when we dealt with the retirement plan example, we enter 6,000 as repeated cash flow because we know how much that repeated constant cash flow is, and we try to solve for future value. But in this case, if we know the loan amount and we know the interest rate and the term to maturity, we need to know how much you have to pay every month. Then you solve for PMT. If you type in PMT, that is the function, the name of the function. Now Excel reminds you the parameters you need to specify. So this is the interest rate, starting with interest rate 4.25%. Because we're trying to solve for monthly payment. So the interest rate and the number of periods, those must be consistent with your cash flow pattern. So this needs to be monthly interest rate, and the number of payments will be 30 years times 12, and the loan amount, that is the present value. I enter a negative present value, so I will have a positive monthly payment. But if you have a positive PV, loan amount enter, then the PMT result will be negative. If you hit enter, it's $2,459.70. That is the monthly payment. So this is basically a direct application of the time value of money calculation that you learned earlier. How about the outstanding loan balance? To figure out the outstanding loan balance, let me just call it time of prepayment. Suppose you want to pay off the loan after 10 years. This is a 30-year loan. How do you find the outstanding loan balance? So in this case, we will be solving for future value because that is a single cash flow that will be repaid. And we have the same interest rate. By the way, the time period, now we're looking at the first 10 years. So that is 10 times 12, 120 months. Now we have a tricky situation because when you look at the first 10 years, the PMT, from a borrower's point of view, PMT is the monthly payment you continue to make. So that is the PMT B15, or the cell reference is the monthly payment. You have $2,459.70. And PV is the $500,000. But there's a problem. If you enter those parameters, telling Excel to go to PMT to take the value and go to loan amount and get that value, and both of them are positive, then you will not be able to get the right answer. The reason is that when you use Excel, you always need to pay attention to the direction of each cash flow. Loan amount from the borrower's point of view is the money you receive. Monthly payment is the money you have to pay. So they represent the opposite direction of cash flows, which means one of them has to be negative. So let's say from a borrower's point of view, you receive the loan amount, so PV is positive, but you have to pay the monthly payment, so PMT is negative. With one of them negative, by changing sign here, you will get $397,216.17. And by the way, this is a negative number because monthly payment is negative. That's the money you pay. Loan amount is the money you receive. Outstanding loan balance is what you need to pay at the end in order to pay off the loan. So after 10 years, you still owe close to $400,000 out of the $500,000 loan. This is how outstanding loan balance is calculated.